So next we have IP address classes. Now our IP address classes allow us to divide up a range of IP addresses between a network and a host segment. Now each of our IP addresses have a network segment and a host segment. The network segment of our IP address tells us what the number of our network we are on is. So our network segment will be a certain part of our IP address. For example, our 192.168.1.1 is going to be a Class C address, and Class C addresses, which we'll talk about in a little bit, have a subnet mask of 255.255.255.0. What is this subnet mask? What does that mean? Well, I'm getting a little bit ahead, but we're just going to go ahead first and then explain it later. So our 192.168.1.1, its subnet mask is going to allow us to know that everything to the left of this line is our network ID, is our net ID. So our network ID is 192.168.1. That's our network that we're on. Every computer inside of our network, every computer that we can connect to without having to go through a router is going to start with 192.168.1. Now, you may say, but wait, I know a friend of mine who lives in a different house than me who has a computer with a 192.168.1 network ID. Well, we'll even go into that later, and when we're talking about public versus private IP addresses. You can set your computer in your home, you can set your network in your home to have a 192.168.1 network ID. That's okay. That's not publicly routable, so it's okay to have that in your private network. But anyway, back to where we are now. We have our network ID, which is our 192.168.1 here, and then our host ID is whatever is remaining, and that is our individual computer. If all of the computers in our network start with 192.168.1, none of our computers are going to have the same host ID, which in this case is 1. So that's our host ID. So let's go back over to our classes. Well, if we have all of our computers on networks like this, then we're going to have a heck of a lot of different possible network combinations. We may have a lot of different networks, but we're not going to be able to have very many hosts because our network ID can be very, very long. We talked about we have our 32-bit addresses. In our network ID segment, which is 3 of our 4 octets, we have 32 minus 8, which is on our last octet. We have 24 total potential binary digits to describe our network ID. So all of these digits beforehand are our potential network IDs. And you change a single one of these binary digits, and you're in the same class of addresses, and you're changing what network you're on. So with this, we can have a ton of different networks, but only itty-bitty little host number. So we mentioned before how we can go from 0 to 255. We need to subtract 2. We need to subtract 2 addresses because one address we can't use as our network identifier. So our .0 we can't use, and then our 255 we can't use. They're possible values, but we can't use them as IP addresses on our computer because 255 is a broadcast, and that'll go to everybody. So we can't use that on our computer. So we have 254 total computers that we can have on this one network. Now, that may seem like a lot if you're setting up a network in your home, but if you're setting a network up in a giant office space and you're trying to get a lot of people on the same network, that's not a lot. 254 may not be as many as you need, or it may be just enough, or it may be too many. It depends on your situation. Thousands and hundreds of thousands of potential different networks may be way more than you may need, or it may be just enough. So essentially, what I'm trying to say is, in our different environments, we need to have different classes of IP addresses. We need to have a way to separate our network ID from our host ID, and we need to have a way to determine how many of these are potential network addresses, how many of these are potential host addresses, and what IP address should I choose in order to decide, I have a big environment where I need a lot of potential hosts, or I have an environment where I need a lot of potential network IDs. I don't need as many hosts. So when IP version 4 was developed, we also developed these different classes. This is called classful IP addressing. And each different class separates our network ID from our host ID at a different point. Tracking me? If not, rewind a little bit. Our IP addresses are separated at different points. Now, our class A addresses are going to be 1.0.0.0 through 126.0.0.0.0. Our class A addresses are going to have a subnet mask of 255.0.0.0. Now remember, I promised you guys that I was going to talk about subnet masks in a little bit. Subnet masks are what let us know what portion of a IP address is a host portion and what portion is the network portion. Let's take a look back over at our binary here. Let's erase our binary. And unfortunately, we're going to get rid of our nice funky little chart here. So 255.0.0.0. Well, what is this really doing in our binary, on our binary level? Well, if we take our 1.0.0.0 address, for example, 0, 0, 0, 0, 0, 0, 0, 1, and then the rest of our octets are all zeros, a bunch of zeros over there. So we have our first octet with all zeros and then 1, and then all zeros, all zeros, all zeros. Our subnet mask, our 255, we mentioned, is our highest number. So when we write out our binary octet can handle. So we write out our subnet mask in binary. You don't have to do this every time because luckily 255 is the highest number. And we see that 255 is all ones and then zeros. So IP address, subnet mask. When we have our IP address and we line it up above our subnet mask, any place where our subnet mask has a 1, any place where our subnet mask is on, means that whatever is on our IP address on that corresponding switch is part of our network address. It's part of our network ID. So all of these are ones. So that means this entire octet would be our network ID. Again, we've got a little bit of help here in our classful addressing. In our subnet mask, and when we're doing subnetting, it's going to be a lot more difficult, but we'll take it one step at a time. We'll walk before we run. Our classful IP addressing, all of our subnet masks are going to be 255s. We notice in Class A it's 255.0.0.0. Class B, it's 255.255.0.0. And Class C, we have 255.255.255.0. So in our Class A addresses, whatever IP address we have, the first octet is our network ID. So the first 8 binary digits, that first octet in our Class A addresses is going to be our network ID. The rest of our addresses the rest of our octets are going to define what hosts we're using. Now, with Class A addresses, this leaves us with at most 254 networks and hundreds of thousands, millions of potential computers. Now, unless we're an internet service provider, we don't need a gigantic Class A address. We may set one on our network just because, but we don't need the full use of a Class A address range, because now we have only at most 254 254 networks, but millions of hosts. So we have our Class B and our Class C. Now our Class B is going to shrink the number of our hosts down, but it's going to increase the number of our potential networks, because now Class B addresses are between the range of 128.0.0.0 through 191.255.0.0. Which means, because our subnet mask in our Class B addresses are 255.255.0.0, our first 2 octets in our Class B address range are going to be our network ID. And then the last 2 octets are going to be our host ID. So if you have an IP address, or you encounter an IP address which is between the range of 128.0.0.0 through 191.255.0.0, these are a Class B addresses. Class A, again, is going to be 1.0.0.0 through 126.0.0.0. Well, what happened to 127? We went from 126 to 128. 127 is going to be used as part of our local host. So if we are, say, pinging the address 127.0.0.1, we're pinging ourselves. We're pinging our own network interface card. We're pinging our own TCP/IP stack. So 127.0.0.1 is used for local host. That's why it's not included in either our Class A or our Class B ranges. Next, we have our Class C range, and Class C is going to jump directly from 191 to 192. Our Class C range is going to include 192.0.0.0 through 223.255.255.0. Now, our Class C ranges are going to have a subnet mask of 255.255.255.0. Hey, look, we have a 192.168.1.1 address up there. That's why we said that our first 3 octets were our network ID and our last octet was our host ID. Because if we look here, we see that our Class C addresses, all of them, have 255.255.255.0 as its subnet mask, which means we line it up, we cut it off. Our first 3 octets are going to be network ID, and our last octet is going to be our hosts. And then lastly, we have our Class D addresses. Now, our Class D addresses are going to be used for multicasting. Now, what is multicasting? Well, multicasting is when we send out data, we send out a packet to a multicasting address, and that address is used to send data to multiple different computers. So our multicasting address range is 224 through 239, 224.0.0.0 through 239.0.0.0, and that will be our multicasting address range. We don't have a subnet mask that we use for this multicasting range, and we won't be assigning this to particular computers or using this as IP addresses other than multicasting. So, just as a quick recap and a way that we can remember these Class A, Class B, and Class C address ranges, let's think about it this way. One of our notable addresses that you'll get to know as you work with computers more, especially if you're around a lot of computer jargon or people that make really nerdy bad jokes, you may hear somebody reference, there's no place like 127.0.0.1, because 127.0.0.1 references your local host, and your local host is the computer you're working at, so it's sort of like your home. So there's no place like, you guys get it. So our Class A address range, the IP address after that is going to be 127.0.0.1. So everything from 1 to 126 is going to be our Class A range. So if you see anything 1 to 126, that's going to be our Class A range. And you can think in your head, okay, 127.0.0.1 is localhost. So anything before localhost is Class A, and then starting at 128 is Class B, right after localhost. And Class B is going to run from 128.0.0.0 through 191.255.0.0. So you think in your head, okay, how can I remember the separation between Class B and Class C then? Well, a very common IP address default for routers that you buy in the store is 192. Because a lot of environments, a lot of small homes and small offices and home offices don't require any more than 254 hosts. So you'll typically get that 192.168. whatever as your net ID for a computer or for a router on a small office. So keep in mind that 192 is going to start off your Class C. So Class A is 1, and then the one afterwards, it ends with localhost. So the one after is localhost, which is the 127. So Class A is 1 through 126. Class B is our IP address after localhost, 128, through 191, right before our standard router that we buy from the store. And then Class C, our typical home or typical office IP address range, is going to be 192 to 223. Now, not quite clever enough to remember how we stop at 223, other than it's one of those things you're going to just have to memorize. That 223 is where we end our Class C address range. And then Class D we pick up with 224 to 239. Well, what about after that? We've talked about earlier how each of our octets can be up to 255, so why do we stop at 239 here for multicasting? Well, after our multicast address range, we're going to have our experimental IP address range, and we're also going to have our broadcast address range. We're not going to include those, however, in these classes, just so we can focus on some of the more critical ones and some of the ones that we really want to learn, but we may address some of those later. But for now, we want to focus on our Class A range, our 1 to 126, Class B range, 128 to 191, Class C range, 192 to 223.255.255. And then also remember that our Class A IP addresses are going to have a subnet mask of 255.0.0.0. Class B IP addresses are going to have a subnet mask of 255.255.0.0, and then Class C address ranges are going to have a subnet mask of 255.255.255.0, and then multicasting.